Welcome to Banana Bytes. In this segment of the podcast, we go live on Data IQ's LinkedIn and Twitter every other week to talk to you about the latest in data science and AI. Our 15-minute bites are here to fuel your afternoon snack time with easy-to-digest food for thought. Everyone, welcome to Banana Bytes. I'm Triveni.
And I'm Will.
And we are the co-hosts of the Banana Data Podcast, which is a podcast about data science, AI, and business, I guess. I don't know. If you're not listening, you should check it out. It's wherever you can subscribe to podcasts. We're there, Banana Data Podcast. And so today for our Banana Bite, we're going to start off with our banana split. You know, this is the idea that we have some topic that there's multiple sides to, a split, if you will. And we want to kind of debate it and see where it takes us. So today we're going to do a deep dive, pun intended, into deep learning. So Will, deep learning, what is it? How is it? When is it? Why is it? Who is it?
Yeah, and who is it for, right?
Who is it for is actually the right question.
These, I think, are all valid questions, but probably to your point about business, something we'll focus on quickly here today. Good one. In the spirit of being argumentative, I'm going to take a strong side here. And I'm going to say no one, we shouldn't be using deep learning.
At all.
Obviously, like full disclaimer, people are going to tune in and be like, this guy's crazy. So everything in balance, right? Everything in moderation. Surely there are times for it. But I have two arguments for you, Triveni, in terms of why I think no to deep learning. You want to hear them?
Yeah, let's hear them.
Okay. So first of all, in my work with deep learning. So by the way, deep learning, neural nets, as far as I'm concerned, we should just think of those two things as synonymous. But so this type of algorithm architecture, technically, they're really good at doing feature extraction. So if I pass in an image, the actual data of an image is like thousands of little pixels, right? So each pixel in itself is kind of meaningless, but in aggregate, like there's some edges, there's some shapes that convey meaning to our brains. And also neural nets are good at kind of understanding in aggregate these features, if you want to call them that, pulling them out, then using these higher order features like our brain does to say, oh, like that's a nose, that's a mouth, those are eyes, this must be a face. So that's how brains work, kind of, as I understand it. That's how neural networks work, kind of, as I understand it. That's great. Here's why I don't think we should be using deep learning. Because we spoke on, I think, our last podcast about specification gaming and how if you're not really intentional about how you design a machine learning or an AI problem for your business, you'll end up optimizing for something that you didn't truly intend. Like that's a real risk, is that you can set up kind of the machine, so to speak. You can start it running, and then you realize that the output or kind of what it's actually doing is not what you truly intended. And I feel like with deep learning, there's a much higher risk of that. Whereas in old school machine learning, where you have like these human data scientists and they're looking at data and they're thinking about this term of feature engineering, like, oh, we should combine, distance from this store with this other feature about a customer. And in aggregate, these 5 features, I think are going to be really predictive. That sort of thoughtfulness, I think it's really important. It leads to performant machine learning models. And then most importantly, I think it allows businesses to more easily get what they want, as opposed to deep learning where you just kind of throw something against the wall. And then I feel like there's a risk that the output might not be exactly what you were looking for. So that's argument number 1.
Well, okay, let me push back on that argument, because I think that there might be use cases where there is no thoughtfulness needed. It's a picture of a cat or it's a picture of a dog. Tell me. Right. And no business is that basic, I hope.
You walked right into my trap, Triveni.
Okay. I'm in the trap. What's next?
So here's argument number 2, and then that's all I've got. And then you can tear me to pieces. So you and I were talking previously about transfer learning. So, maybe in a little bit you can explain kind of to the audience what transfer learning is if they're unfamiliar. I do think that transfer learning, or using the output of pre-trained neural net models, is good and important. So the way I think about this is like right now I'm talking to you on my Apple MacBook computer. If I'm a business, I need computers to do business. I'm not going to build my own computer. I'm going to go pay Apple to do it, and I'm going to use an Apple laptop. Similarly, I think the best in class NLP or computer vision or audio, visual, video algorithms they're taking tons of bright people, tons of computing resources, and tons of time. And Google is like handcrafting these algorithms, and then they're open sourcing them to the world. So I feel like business leaders should be thinking of the deep learning models that their data scientists may be using the way that you and I think about our laptops. We would never build a laptop as Dataiku employees. We just buy it and use it. Similarly, I feel like the vast majority of organizations shouldn't try to, from the ground up, train deep learning models. They should just use them the way I use my laptop from Apple. They should use them from Google or Facebook or something.
Okay, so basically what you've done is now answered a different question, right?
Oh.
The question first being, should everyone use neural nets? And now the question really is, should everyone build neural nets, right? And
Touché.
Your point, which I think is very accurate and very fair, is that you don't need to build a neural net from scratch. Probably 80% of the time, there is a pre-trained image model out there, or a pre-trained video, or a pre-trained speech model, whatever it is out there. And all you need to do is do some transfer learning. So transfer learning, just to bring that point back, is the idea that you can take a model that's already been trained. Google has trained a model to recognize images. And so the very baseline fundamentals of nose and eye and, colors or shapes have been taught to this model. But now you want to make that model a little bit more refined or, specific to your use case. So one idea might be, hey, I'm going to show you pictures of things around my house and tell me if I can recycle it or not.
Mm-hmm.
So I need to retrain that model with new information, because the model doesn't have enough information about, is a cup recyclable? Is a newspaper recyclable?
Your specific use case.
My specific use case, right? And so what I'm going to do is retrain the last few layers of that big pre-made model with my specific data or my training data. And in doing so, I'm making my model, more efficient for my need. And I'm transferring the learning from the larger model to a more nuanced model.
Yeah, I would definitely, if people watching haven't heard of transfer learning or they're not familiar with it, definitely, whether you're a data scientist or a business leader, strongly encourage you to check that out. Big fan of transfer learning. Big
fan over here. But yeah, so I think in that sense, no, not everybody needs to be building a neural network, because you probably already have it. And given the fact that they're really computationally expensive, both like money and time,
computationally expensive, which means monetarily expensive. So,
just like actually monetarily expensive to build. Why would you do that, right? Unless there's a very specific need or you're a researcher somewhere. But so I think, yes, so I don't think not everybody needs to build neural networks, but also not everybody needs to use a neural network or deep learning. There are cases where it's important. The example I just gave with like recycling items. Yeah, you're not going to do that as well with a prediction from like a random forest model.
So speaking of random forest model, let's open up another can of worms. We don't have a ton of time here on this banana split, but just to be brief about it, we on our podcast like to talk about the use cases of models and ethical use of models and model interpretability and the concepts of black box and white box models. So you walked right into it. I'm going to ask you, what's your hot take? Neural nets and black box and lack of interpretability. Is that valid? Is that a concern? If I'm thinking about model performance, should I be scared off from neural nets because maybe they're performant, but they're not interpretable?
I mean, if anyone's listened to even a single episode of our podcast, they already know the answer, which is, yeah, if you can't interpret it, you probably should be afraid of it. In that, sometimes, okay, let me caveat that. There are times where I just, I love to go big and then be like, wait, hold on. So there are times where you're going to build a model and it actually doesn't matter if you can interpret it, because you just need the output, right? Like if I have a model that's classifying recycling items, I don't really care why it thinks this is a piece of paper I can recycle. I just need to know what to do with it.
Yep.
Now, if I'm building a model to predict if someone's going to get cancer or should be denied a loan, then yeah, I need to know why this model made that decision. Otherwise, I'm running the risk of a lot of biases and a lot of like misinformation being fed into a model. So the black box and non-interpretability of neural networks or deep learning is only a problem when your question isn't right for a neural network. And that's kind of what I'm getting at with the maybe, in that there are times where you just need something that complex because your input data is so complex. And in other times you don't.
I like your distinction there, which it's totally true. At least I think it's true that if I'm thinking about, whether or not this apple peel should be recycled or not, I really don't care what core features of the apple it's looking at to determine that needs to be composted and not recycled or whatever. I think another point that I'd like to bring up is that this is me now defending deep learning, right? So for people, just to give you the truth, I'm on both sides here. I'm on both sides. I think that deep learning has a bad rap because people say it's all black box. It's all so uninterpretable. And they say, oh, but like other traditional machine learning algorithms are much more interpretable. And I think that's unfair because I think you could talk about linear regression or a really popular class of algorithms that people use in this day and age is like that of the forest or the tree-based algorithms. And so oftentimes, if you're familiar with those, after you train a tree-based model, software packages like in Dataiku will report to you, these are the feature importances. So, the person's, zip code was the most important feature here in making this prediction. And I think people just see that and they smile and they nod and like, oh, that's great. That's a really strongly important feature. But very few people actually think about like node impurity and how these splits are actually made and how we're taking the math of the underlying model and then like for the business user presenting it as feature importance. Like they kind of wave their hands. And in that way, I think that other models are not so good. And similarly with neural nets, there are ways that I could like roughly approximate all of what's happening internally with the nodes and the weights and the biases. And I could say, hey, like roughly speaking, these are some inputs that I think tend to be contributing strongly or weakly to the outputs. So again, like in synopsis, I don't think people should, hopefully they'll come away from this banana bite and they'll think, actually, maybe Will's right. Like neural nets are not so obscure that should totally scare us off. If you think they're really performant and you're worried about their obscurity, maybe hire me or you, Trevania. We can do some consulting. And like, it's not impossible to understand the internal workings of a neural net. So you shouldn't just give up straight away.
Yeah, you can hire Will at www.where'swill.com.
Yeah.
So I think you're right on that. The interpretability issue is not just unique to neural networks. Every algorithm suffers from that problem, and that's why we now have all of these new ideas and tools and methods to address that. So yeah, I think you're right that it gets a bad rap, but at the same time, I think that neural networks are still more dense and complicated than anything else. And so I wouldn't necessarily say that, because everything is hard to interpret, neural networks should get a pass.
Yeah. And this is going to be me. Apologies for saying something that's hopefully cliched and not really that insightful. But if you're starting an organization and it's like we've discussed previously, an AI business and like AI or ML is at the core of your organization, it should, I would argue, and again, someone on the line, feel free to disagree, it should never be deep learning first. Or if you're an enterprise and you're an enterprise organization that says, hey, my team, we have all this data. Previously, we've just kind of made this decision process in a purely human-based way, but we want to kind of supplement with machine learning techniques. It should never be deep learning first for so many reasons. So I would imagine you agree with that. I would imagine that's obvious, but just want to go on record and say that always start simple in machine learning and AI and then grow in complexity as you need.
Yeah, definitely. I mean, I think that's a lesson for anybody, but not to be totally afraid of what deep learning or neural nets can bring to your question or to your organization. But to be very cognizant of the costs right up front and not just expecting that, we'll just throw it into a deep learning algorithm and then everything will be fixed, because that's not always the case.
Yeah, I think on this point, it would be interesting. And unfortunately, I don't have this data on hand. I don't know if anyone does. Again, write to us if you know. But I realize this is kind of a blunt question. It's not the best question. But if I'm an organization and I've got a model that's a linear regression or a logistic regression, and it's kind of at a certain level of performance, are there any heuristics, any really, really rough heuristics they would have to be, where I could say, if I invested in like a custom neural net based architecture, could I expect to see a performance increase? And if so, by how much? I would imagine that the hardcore data scientists out there, the statisticians, would just throw me under the bus for asking such kind of a ignorant and naive question. But if you're someone who's leading a data team and you even had like a rough idea of that, a rough literature review of kind of different classification problems and how types of algorithms compared, that would be a useful starting place.
Yeah. So if anyone's interested in doing that, talk to Will.
Yeah.
So that's all the time we have for today's Byte. Thank you so much for hanging out, Will. And if you all enjoyed what you heard / saw, I don't think you enjoyed the seeing part, but if you enjoyed what you heard, check out the Banana Data podcast on wherever you listen to podcasts. See you next time.
See you, Triveni.
And that's all we have for our Banana Bytes today. To catch our live segments, follow Data IQ on LinkedIn or Twitter for bi-weekly live streams.